Hey guys, this is my first interactive video and I'll be posting here about graphs. Now, I'm pretty sure that many of you who are watching my channel must be aware what actually a graph is. So, any mathematical equation when plotted on the Cartesian or XY plane gives a particular curve, and that curve is called the graph of that equation, such as some trigonometric curve like sin x, or some inverse trigonometric curve sin inverse x, or even some algebraic curves like x square or x cube or even x raised to power 4. Even you can also plot some conics such as equation of a circle. Now when you change the values of r, you can obtain circles of different sizes, and maybe you can plot some any other conic such as ellipse equal to 1, maybe. Yeah, so horizontal ellipse, or maybe if you change the values like 4 and 9, so you'll obtain a vertical ellipse. Or maybe a parabola, changing the values of a, you'll obtain different types of parabolas. So all these equations will give you a particular curve. Now what I will be doing is, with the help of such different kind of combinations of these mathematical equations, I'll be plotting some beautiful geometric arrangements. So let me show you something. This is a smiling face, and these are all these equations through which I made this curve. So you can see this equation of a circle, equation of a circle, equation of an ellipse, and yes, most important part is the inequality. Basically, inequality helps me to constrain the curve from in a particular region where I want it. Had it been, if I remove this inequality, suppose if I just simply delete this inequality, I will obtain a symmetric curve. And even if I remove this entire inequality on x, it would give me a complete ellipse. I don't want that. I just want to I want this part only. So it's giving me a smile. Or something like this, maybe a heart. Okay, I know it's not looking like a perfect heart, but yeah, you can understand. And these were the equations. So in this video I'll be just explaining you about some features of Desmos which it provides us. So yeah, let's start off. So the very first feature that Desmos provides us is the polar coordinate. Basically, suppose you have to draw a circle, you will write it as x square plus y square equal to 100. Then you can see you have obtained a circle centered at the origin. Now this equation is okay, but it's kind of looking very long. Instead, what I can do is just simply plug in r equal to 10, and boom, it has also plotted the same curve which I have previously done with the algebraic equation. Now what basically I have done with r equal to 10, so r is basically the distance of a point from origin. It's r, and r equal to 10 is the locus of all such points which are at a distance of 10 units from the origin, which is basically a circle of radius 10. So you can see how easy it is to draw a circle in polar coordinates. And the only drawback which I feel of the polar coordinates is we can't draw a circle like a shifted circle. It will only give you a circle centered at the origin. And to be honest, I don't feel this much as a big drawback, because if I have to draw a circle which is shifted, then I can simply shift my graph like this. So whenever in the future I will be requiring a circle, I will simply use the polar coordinates. And not only in the circle, if I have to draw something like r equal to theta, sorry, r equal to theta, it will give me a spiral. And we can also change the limits of theta ranging from like 0 to maybe 2 pi, or maybe 10 pi, sorry, yeah. So polar coordinates, and yeah, if I have to write the same equation like r equal to theta in the algebraic form, I would have to do something like this: x square plus y square raised to the power of 1 by 2, which is the r, like x square plus y square square root of x square plus y square gives us the distance of that point xy from the origin, is equal to theta. Theta is basically tan inverse of arctan of y by x. So yeah, now tan inverse y by x has its own limitations. You can see we haven't got a full spiral. But if you look at this figure closely, if we rotate this figure if not rotate, basically if we find the mirror of the image of this figure with respect to the y-axis, we will obtain an S looking figure. So okay, let's keep that in mind. If whenever we have to draw S, we can use this r equal to theta form in the algebraic form. So one more cool feature that Desmos provides us is the list feature. So suppose I create a list L with elements like 1, 2, 3, 4 and 5, and then I have to draw 5 concentric circles centered at the origin. So I'll just simply write it as r equal to L. Now what it does is it's basically abstracts the value of the radius from the list L one by one. First it draws a circle of unit radius, that is 1, then it draws a circle of radius 2, then 3 and 4 and 5 and so on. Now let's suppose I have to create 100 concentric circles or maybe 50 concentric circles. So I'm not going to write like numbers from 1 to 50. Instead I'll just simply write 3 dots and then 50. So you can see that the graph has been created of 50 concentric circles. So this is actually a very useful feature, and not only in just circles, also you can also create multiple parabolas. Sorry, I don't know why I just deleted the list. Let's make a new one. And 5, yeah. So let's suppose we have to draw a parabola LX, or maybe some different one. Oh no, 4 and 5 and x square equal to 4ly. So yes, you can see that 5 parabolas have been drawn of different sizes. Again, the vertex is at the origin, and I've just replaced a with L. Now the graph will abstract the values of a from the list L one by one, and so this is a very useful feature. Now there's one more feature which Desmos provides, that is, suppose you write fx equal to 1 plus sine x. Now you click on the settings tab, and there you can see the create table feature. Okay, so it basically creates a tabular form of data where you can plug in the values of x, like suppose I put in x as minus pi. So for x equal to minus pi, the corresponding y is 1, and suppose you can fill in multiple values such as, and You can see the data, the tabular data. Also, you can see the points have been marked there on the graph, and you can change the style of these points again by the same thing. Like you can change it to green, orange, blue, and also you can change the size from open circle to basically close, or even cross, square, asterisk, rhombus, triangle, anything which you want. So this is also a very good feature, just to highlight the points on the graph or to mark them. Now most of the features which Desmos provides us and which we will be using, I've taken them in this video. Now I will be giving you guys some alphabets to plot them on the graph using equations. So starting off with A. Now A is basically just two lines and one horizontal line. So it's, if you see, it's basically an inverted V, these two lines. It's inverted V, so you can easily draw the graph of mod x and then a horizontal line. B is quite difficult, you can try it. C is easy, just a what we call hemisphere. No, semicircle, sorry, semicircle, yeah. So C is a semicircle, D is also a semicircle with just a vertical line. E is also a straight line, vertical line with three horizontal lines. F is much similar to E only. G is also a semicircle with a vertical and a horizontal line. H is easy, I is easy. J is quite different, you can try it. K is much similar to a vertical line and to this V-shaped mod X graph, sidewise mod X. L is easy, M you can try, N is much similar to M only, O is the easiest, I guess, just a circle. P is one vertical line and a semicircle. Q is similar to O only, just a circle and a straight line. R is much similar to P only. S you can try, I've already told you how you can try S. Now T is also easy. Now U is a pretty good one, because if you see all these alphabets, then most of them are requiring, most, in fact every alphabet requires a straight line and a semicircle or a full circle. But in case of U, it's different from others, so you can try this one. V is just mod X only. W, yes, you can try W. It's basically a upgraded mod X graph. X is easy, two intersecting lines. Y is just X only. If you remove this portion from X, it will give you a Y curve. And Z is also easy. So yeah, you can try out these alphabets B, J, S, M, and U and W, and I'll take them up in the next video. Till then, keep watching. Thank you.